Linux, you can do most system administration from the command line, but sometimes if you're using your system as a workstation or need to run applications that have graphical interfaces or utilities for system administration that have graphical interfaces, then you need xwindows. Um, if uh, Last time we touched the etc in a tab, we told it basically to have a default run level of 3, and 3 is full multi-user mode, so you can run all kinds of services on there, but you cannot display anything graphical. To go into xwindows and have graphics, you have to go into run level 5. And the easiest way to go to run level 5 is to use the command startx. So right here we're in init level 3, and to go to run level 5, we just run the command startx. But first, before we run startx, we need to make sure that we have the service xfs running. XFS is the xwindows font server, and it needs to be running as a requirement prior to starting X. So let's check and see if it's running. We do that with service xfs status. So you can see it's running with process ID 2845, so that's good. So we'll go ahead and start X. Start X will basically start the X Windows manager, which in my case the default is GNOME, and basically the Windows manager just manages all your X applications and gives you an interface to to open different X Windows programs. Um, the first thing you need to know is that to configure your resolution, your monitor type, and your video card, um, you can run the command system config display, and this tool basically will allow you to configure all those settings. Um, xwindows is a client server program, so what that means is you can run xwindows applications like this terminal, which exists on this machine, which is tlos1, so it's my virtual machine. But I can also run applications that exist on other machines. And to control which applications can run on this machine, I use the command xhost. So if I run xhost minus and I put a host name, I can deny access to that host name. If I just put xhost minus, it will deny access to run xwindows applications uh, on this xwindows server from any other machine. So if I do x host minus, it's access control enable, only authorized clients can connect. Okay, so if I open another terminal, and in this case I'm in CSE 570E. So here I'm on CSE 570E, and what I want to do is display the genome terminal of CSE 570E on tlos1. So to do that, I need to set the environment variable display to be equal to tlos1. So I do that with the export command. So I export the variable display, which equals tlos1 .csc 570e.edu, which is the host name of this xwindows server. And then you can run multiple instances of xwindows. So the first instance that runs is usually 0, so we'll put :0. So once I run that command on CSE 570E, what that tells the shell is that anything that I run here will actually display on tlos1. So let's test that. Genome terminal. So I'm going to run it there. And as you can see, it failed. And the reason it failed is because I put xhost minus. So if I actually want it to work, I could do xhost plus to allow everybody, or I could do xhost plus csc 570e.urs.edu. And that will give access to run that application from CHC 570E. So we'll wait for that prompt to come back. in the, okay, so it came back and it was added. So now I can go and run genome terminal again from CSC 570E, and hopefully it will display here at TLOS1. So it's refused again. So just to be safe, I'm gonna do xhost plus. This should allow access from anybody. And now I'll run it. Looks like it's having problem resolving this particular host name. But when I did everybody, it didn't allow it. So see the difference here? This genome terminal that I open, it's actually for CSE 570E. See, it's a remote application. This is my terminal here that I opened on TLOS1, and this is the one that I opened from PuTTY from CSE 570E, telling it to display here. So as you can see, xwindows is client server. You can run things locally, or you can run things from another machine, applications from a different machine, and you control that with the xhost command, xhost plus or xhost minus, and then the host name, which in this case was CSC 570E. One more thing, when you go into init level 5, run level 5, and you're running xwindows listens on port 6000. So let's verify that. netstat minus net p pipe grep x, and as you can see, it's listening on all IPs on port 6000. So that's why when I open genome session from CSE 570E, it was able to display it here because it was listening, X was listening on that port. The next thing I'm going to talk about is printing. To configure printing on a Linux machine, we use the printer configuration tool to set up a printer, and that tool is, you can call it with the command system config printer. And from here, you can add a new queue, a new print queue, by clicking on new. And this will basically open a wizard that will guide you through the setup of a printer. For Linux systems, the protocol for most printing is the most popular and default protocol for printing is CUPS, or the Common Unix Printing System. And here I'm going to configure actually a CUPS printer that exists on CSC 570E. So I'm going to call it CSC 570E printer. I'm going to give it a description of CSC 570E printer. We'll go forward. And then here I can select a local printer attached to my machine, or in my case, it's a network CUPS machine, network CUPS printer. CUPS by default uses the Internet Printing Protocol, which is the default, like I said, for Linux, and now Mac uses it as well. Eventually, Windows systems will also use CUPS. So I'm going to put CUPS, and when you configure a CUPS printer, you need to put the server name and also the path to the printer on the server. So in my case, my server is csc570e.us.edu, and the path is printers and Q1, which is the default. I'll go forward, and it's going to ask me what type of printer this is. In my case, I'm just going to make it a text-only printer, and I'm going to finish. It's probably going to ask me if I want to print the test page, and I'm going to say yes. And when I do this, basically this printer configuration tool, it's going into the etc cups directory, and it's modifying the files inside there. So if you know what you're doing, you can actually VI those files and create the entries like that. Or you could use this tool, which basically is a graphical interface to edit those files. Here's telling me that it's connecting to the printer. And cups actually listens on port 631. So if we connect it to CSE 570E on port 631, we can actually manage the job and see what's printed there. So I'm going to use elinks, which is a browser from the terminal, and I'm going to connect to http://csc 570e.us.edu:631, and this is where CUPS listens, and it also has a nice management interface to manage the jobs. So see, from this interface here, I can manage the printers and manage the jobs and do administration tasks. So if I wanted to see if my print job went through, I could go down to manage jobs and see if my print job went through. Show completed jobs will show me that my print job was completed. So to quit, I just do a Q, yes, and that's basically how to configure a printer on the Linux machine. The next thing we're going to talk about is system logs. On Linux, the syslog service runs by default when you install Linux, and if we do a service syslog status, we can see that it's actually running two different daemons, the syslogd and the klogd. Syslogd logs all the system logs, and klogd logs all the kernel type logs. Syslogd is actually configured in the etc syslog file. So let's look at that file via etc syslog.conf. Actually, it's etc syslog.conf. And in this file, basically, we configure where do we want to send the logs for different things. So anything here, we're saying that anything related to mail services, we're going to send to the var log mail log file. Anything with cron, which is a scheduling service to schedule tasks, we're going to send to the var log cron. And then anything, then we want to log everything except mail of log level info, because there are different types of log verbosity with logs. You have info, and you have, I think debug is the highest verbosity. So here we're saying log anything except mail none of level info, start that info or higher to this file var log messages. So that's basically where most of our system log information is going to go to. So we can actually go and look at that file. If you're debugging something, it's always a good idea to, if you go to the var log directory, in here you will see all your different logs. Okay, so there is a utility that runs in the background that basically it's called log rotate, and it rotates all of your logs on a weekly basis, because these logs can get pretty big quickly, especially if you're running into issues. So here you can see we have our cron for logs about cron. We have our mail log for information on mail services. Spooler for printing stuff. Secure is an important log which tells you tel -f. Basically, it tells you it audits who's logged in to the system. And if I do another tel -f on var log messages, this is the main syslog. So for example, here I'm on TLOS 1, and this one here is CSE570E. So if I SSH into from CSE570E to TLOS1, which is this machine here, it should add an entry to the log. So here, as you can see, it told me that at 11:42 TLOS1 using SSH and through PAM logged in as the user root. So if you're having problems with different services not starting, or want to look at things that are failing on your system, it's always a good idea to look at this var log messages, which is basically where the log information is found. Um, Alternatively, there is a nice GUI interface utility that you can use to sift through your logs, and that tool is called System Log Viewer. And basically what this tool does is it provides you a GUI interface to all those logs we just looked at. So there's the boot log, the cron log, and here's the system log, which is that last one we just looked at. So that entry, that root connected through SSH is right there. So it allows you to filter and look for stuff when you're looking for stuff. X.RX11 log is your xwindows log. So if you're having problems with displays and things are not looking right, then you can go and look at that log and see what your problems are. When your machine boots, it puts out all these different kernel logs about your hardware. So that's one that you can look at to find out what kind of hardware you're running, or if you have any hardware issues on your machine. So that's basically logging. I'm going to close that. The next thing we're going to talk about is cron. Cron is basically a tool that it's used to schedule the execution of recurring tasks. And you can manage jobs in cron two different ways. One is by creating a file in the etc cron.d directory. And if you can see that sysstat RPM that we installed last week has an entry there. So let's take a look at that entry. So I'm going to run more on sysstat. And basically what this says is that there's different parameters here, okay? And there's 2, 4, 5, and then a user, and then a command. So here what it's saying is the first entry is the minute. So at 53 minutes, and the second one is hour, which is at 23. So at 11:53 p.m. And then for the next one is day, then month, and then day of the week. Okay, so here when you put start, that means every day, every month, and every day of the week at 11:53 p.m. run the command user lib sa sa2, which is the SAR utility, which gets all the let's do a man on sa2. Basically, what it does is it writes a daily report in the var log sa of all your different tools that you have, such as IOStat, VMstat, to check different things like memory, IO, CPU usage, and that kind of stuff. So, but the main thing here is that cron jobs have these type of settings here, which these are again the minutes, this is the hour, this is the day, this is the month, and this is the day of the week, this is the user that you want to run it as, and this is that command. So to create or schedule a job like this one we did here, we would tell it when and at what time and what day and what minute, hour, day, the user that we want to run it as, and the actual command that we want to run. And if we put it here in the cron.d directory, the service cron will go there and check it there and run it. So if we run service cron status, it's actually cron D, I think. See, cron D is running on this machine, so it will periodically check there, and it knows that at 11:53 p.m. it's going to go ahead and execute that command. But you can also do this by running the command cron tab -e to edit the cron tab file. The cron tab file just resides in the etc directory, and that's where it keeps track of all the different commands you want to schedule for execution at different times. So if you do cron tab -e, it basically opens a VI terminal, and then you can actually paste in there your different cron jobs. Again, this one says at 53 minutes of 11:23 hour every day, every month, and every day of the year, as the user root, run this command. But I could do this for different things. One that comes to mind is the log rotate. So remember I said before that sometimes we want to rotate those logs once a week. So for that one, I could do at 0 hours, um, 23, so at 11 p.m. every month. But this time I'm gonna do it on, I think 0 is Sunday, so on Sundays. So actually the 0 is gonna be here, the hour day, star, star, 0 as the user root, run the command it's been log rotate. So that's how I would configure that one to run. I'm gonna quit and not save it. And for more information on cron tab, I could do a manual cron tab. And here it basically gives me all the different settings. But the one I use was the cron tab -e, which is to edit the cron tab. Okay. And then finally, to do a backup of your system, there are several tools you can use, but last week we talked a little bit about tar, and I want to talk even more about tar this week. Tar is nice because it allows you to create a package, and this package can contain directories as well as files, and it's very useful in in creating backups. To create a tar of a directory, you run the command tar and then -c to create. Tar, like I said before, was originally intended to use with tape drives. So when you actually want to create a file, a tar file, you have to put the F command, so tar -cf, because it's a file. And then if you want to compress it, you can zip it with Z. And then to see verbose output of every file that gets compressed, you could put V. Okay, and then the next parameter is the name of the tar file you want to create, which in my case is going to be home.tar.gc. So I'm gonna tar the entire home directory. I'm gonna create a tar file that is gunzip, so compress, and /home. So this says create a tar file that is compressed of directory /home, and make sure you create that in home.tar.gc. So I'm gonna run that. Actually, the F needs to be at the end, so that's why it didn't work. because F says this file, so it's the last one. So here I've created a tar, so if I do a ls minus lh, I can see that I have a tar file now. So if I do make dir temp and I move my home file there, and then now I cd to the directory, I can see that my file is there. So to uncompress and extract the contents of this tar, I could do the command tar. Instead of C to create, I'm gonna do minus X. Okay, I still want it verbose to see what uncompresses. It's still gonna be it's gonna be it's gonna be it's gonna be Z because it's zipped, and it's gonna be F because it's a file, and then the file name, which is home.targc. So see that uncompresses, and actually I still have a home directory. Then I have my NIS student, and my student directory is there, and I can go into student and see what files are there. There's nothing. I can go into student and see that it backed up all those files. So as you can see, tar can be used to create backups of a system, uh, partition or individual directories, or however you want to do it. Alternatively, for your backups, you could use the dump and restore utilities, but I found that tar, it's much easier to use. Another tool that some people use is the CPIO, but again, tar is the easiest one.